Okay, the next part we are going to look at bond breaking and bond forming in a chemical reaction. So we know that in a chemical reaction, I have to break these bonds, break the bonds of your reactants, right? Then their atoms rearrange and then they form new bonds of your product. Okay, so a chemical reaction involves the breaking of chemical bonds and then the formation of new bonds. And this will involve energy change, right? Bond breaking takes in the energy, it absorbs energy and is endothermic. Okay, why? I want to break something. Of course, I need the energy to break it. So how do I break it? I absorb in the energy. Okay, and bond forming gives out energy. Why do elements form bond again? Because it is stable. Stable means low energy. All right, so what happens? These bonds are rearranged and this energy is given out to the surrounding, exothermic, when bonds are being formed. Okay, so to break bonds, need to absorb is endothermic. To form bonds, right? Again, this is to achieve noble gas. This is low energy level. It is stable and it's exothermic. Okay, so enthalpy change, we give it the symbol delta H. This is the difference between energy level of reactants and products. Okay, so essentially this energy change, enthalpy change, is how much energy is in a reaction after it takes place, right? This reaction, when it takes place, how much energy is there? Okay, so this is the difference between the energy level of reactants and product. Okay, so if less energy is absorbed to break than released to form. So for example, if I want to break a bond, I need 500 kilojoules, right? And then as with all reactions, I have to break this bond first before I form it. So 500 is absorbed to break it. Then I minus away whatever the energy that's required to form the bonds. An example, if there is more energy required, so 1000 kilojoules. Okay, so this is less energy, this is more energy. My overall delta H in this reaction will be negative 500. And this negative 500 is exothermic. Why? Because this part is forming and forming is exo. So the overall negative value of your enthalpy change is exothermic. Okay, if more energy is absorbed to break than to release. So example, now I need to absorb 1000 kilojoules to break this. And I release out 500 joules when the new substances are formed. Right? So overall reaction of this will be a positive 500 kilojoules. Right? So this one is I absorb. Correct? I absorb in and then this is released to form. So I have a high number when it is absorbed. There's more energy absorbed and a smaller number release, right? This one will give me a positive enthalpy change, and this is energy being absorbed in. Absorbed in is endothermic.
Okay, this example over here, right, is a typical example of what you will get in the exam and the expectations of what you have to write. Okay, in terms of bond breaking, bond forming, and explaining why some reactions are exothermic or endothermic. Okay, so explain in terms of bond forming, bond breaking, reaction with hydrogen and oxygen is exothermic. So write your equation, hydrogen plus oxygen give me water, and the question tells me it's exothermic. Even if the question never tell you, you have to know it's exothermic because combustion reaction is exothermic. Okay, so the overall idea over here is exothermic. This is energy release. So this energy release must be larger than energy absorbed. Right? So if I have a energy release is larger, then the overall reaction is releasing this energy. Okay, so what is the delta H of this, right? So the delta H or the enthalpy change is always to absorb to break, then release to form, right? So absorb to break, and to get a negative value, absorb to break must be a small number. Okay, and this number must be smaller than to form. Okay, so after you have digested this idea, then let's write down answer scheme, what we have to write. Energy required to break the bond. So in all your chemical reactions, we break it first, then we form. So break the bond must be smaller. Why? Because overall, then I can get a negative value exothermic reaction. Okay, it is smaller than the energy required to form the bonds in water. Okay, and then in the exams, this is your expectations of what to write. Okay, the formation of water is exothermic because combustion reaction. And then exothermic, you have to know the delta H, the enthalpy change is negative. As the energy taken in to break 2 moles of hydrogen bonds and 1 mole of oxygen bond is, to get a negative value, it must be smaller than the energy given out or released to form 4 moles of OH bonds. Okay, if you're not very sure why is there H single bond and O double bond, this one is your covalent bonding. Okay, to achieve noble gas configuration, my hydrogen, okay, can only form covalent this way. This is your single bond. My oxygen, to achieve noble gas, can only form a double bond this way. Okay, so my oxygen has a double bond, right, over here, and 2 moles of hydrogen single bond, because in a balanced equation, there's 2 molecules, so I'm breaking this one times 2. Okay, this one, the energy absorbed to break must be smaller than energy released to form. Okay, so let's look at bond formation. My forming water, H2O, again covalent. To achieve noble gas, it should look something like this, my water. Okay, so there is 1 OH bond here and 2 OH bond. But why is 4? Is because in a balanced equation, there's 2 molecules. Okay, so I need to have 4 OH bonds. All right, and the energy released to form this must be bigger energy released to form. Okay, so the energy absorbed must be smaller than the energy given out to form. And this is my standard answer to write. Okay, in terms of marking scheme, what are they looking for? Exothermic, delta H is negative. Energy absorbed to break. How many moles? They are really looking for this. Okay, is bigger or smaller than energy released to form how many moles? All of these parts essentially is the whole part that I have to write, to get your full mark.